Welcome friends, let us move to lecture 4. Today we will be more focused on product design morphologies. I am sure you would have done the last assignments which I have given it at the end of the lecture, and all these assignments are only to make sure that you start enjoying this course. So, let us move on to lecture 4. So, in lecture 4 the content will be developing provisional designs, then evaluation and decision making, and then morphology of design. There are 7 steps, we will go through all the 7 steps. So, establishing function, that is very important. So, here what we see is setting requirements and developing specifications. See, I was telling you last time also that I need a soft cloth. So, what is your soft requirement? So, it is very difficult for anybody to quantify the softness. For example, if you take a tea taster, there are tea tasters appointed by tea processing industry. They try to test a tea and then they say this is good or bad. So, it is only they can do it. It is very difficult for you to replace them by some machine. So, changing customers' requirement into engineering specification is a big art. Many a times you will not be able to give a direct specification. So, we try to give it indirect. For example, we will try to say okay, the touch has to be as soft as a skin of an animal, or it has to be as soft as a silk sari. So, then what do we do is we go measure the silk sari softness, and then that we try to establish in terms of known parameters like tensile strength, this and that, and then we try to indirectly give the specifications. So, that is what is a big challenge in design, that is a very big challenge. So, a weight or a relative importance is assigned to each attributes. So, that is what I said, indirect way of going ahead, or you try to give a weightage. The other thing is, suppose if there are 10 specifications you come. So, these are the specifications for a product. So, then you will try to give in this 10 specifications which are all significant and which are all non-significant. So, in non-significant parameters, right. So, in this non-significant parameters and significant parameters, again you would like to assign weightages, and you try to say which specification is more important. For example, when you take a child's diaper, the softness is very important. So, is it the softness important or the absorption capability of the water important? Both are important. First comes water, then comes the softness. If you have a soft diaper, but not a water absorbing diaper, then it leads to the failure of the product. So, here a weight or a relative importance is assigned to each attribute. The value of the strength of the product can be got through multiplying weightages and their relationship score. So, basically what we are trying to do is, we are trying to say you multiply with x, you multiply with maybe x1, x2, x3, and then what you do is you try to have a final score here. And then what you do is you try to find out from that score what is the importance. So, generally when we try to give weightages can be given 0 to 1, it can be given 0 to 10, it can be given 0 to 100. More the weightage number, more will be the demarcation which you can show. The target value of each parameter is set on the basis of the importance and the competitor's product. So, now what is happening? You have found out the weightages. Now, after finding these weightages, what you do is you have found out this is a very significant parameter. Fine. So, now what you will do? You will go to the market and find out who else are doing a similar product, and in that similarity, for example, two things are there. Let us go back to the diaper example. So, what you do is you go around the market and look for water absorbing products. It can be tissue paper, it can be anything, right. So, you will look forward and you will try to take the best fellow. For example, X company is producing a diaper, or it is trying to produce a cloth, tissue paper which has the best absorbing. So, you try to take that and keep it aside. Then what you do? You go around the market and look at similar products for smoothenings, and then you try to find out a kerchief is very smooth. some X kerchief is very smooth. So, now you take that fellow and keep it aside. So, now what you will do is you have now done the state of the art for these two things which are pioneer in their own domains, and now you try to take their specification and then try to look at the current state of the art in diaper, what is all available, and then see where to pitch in, what to pitch in, and then you decide the specification. So, deciding specification is very, very, very important. If somebody buys a mobile phone today, he says, I would like to buy a mobile phone which need not get charged for 7 days. Practically, yes, it should be possible, but the deciding factor is going to be the battery life. And there are two things. If you say that battery life, then you should have a powerful battery. The other way around is, if I have a phone which does not have so many features, then still I can produce a mobile phone which can meet out to the customer requirement of not charging for 7 days. So, you see, now it is a contradicting thing. So, now you should understand what customer wants, what is competitive available, and then decide your specification. If you make a mistake in assigning the specification, then all the other exercise will be going futile. So, setting requirements and developing specification is a very, very important task. So, then what you do is you try to develop provisional designs. So, many innovative ideas can be attributed to chance. These type of analogies are encouraged. Direct analogy. In direct analogy, what happens is, it involves an analogy of problem situation. You try to take a situation and or you try to take a problem situation from a very different field, from a field which is different. Okay. So, then you try to compare. For example, you try to say the specimen or the food whatever is kept in front of me is very hot. So, what you do is you try to put an analogy of a chili and try to increase the red color which is given to the chili. So, now food is something, chili is some other thing. So, now you are trying to compare, or you can try to take hot and then you can try to put fire and say, okay, this specimen or this food item is very hot. So, you can just try to put an analogy with respect to even fire. So, here what is happening is, you try to take an analogy from a problem situation from very different field and try to link it with your thing. The next one is personal analogy. Personal analogy is, here it is expected to project himself or herself into a situation, and then you try to and you try to report that. Okay. You report the experience of that particular situation back into your analogy. Say for example, I touched some item which is very soft. So, here what did you do? You touched, you project yourself, himself or herself into a situation and then report the feelings like seeing, hearing, etc., etc. What is symbolic? Symbolic means it is something like a poetic, or you try to create a paradoxical phrase. So, that is symbolic analogy. So, I was recently using a urinal in an airport. There was a small phrase written. So, it said flush and rush. So, it is something like poetic, right. So, this is, and then you can also use something like a phrase like this and then try to bring it to your design. And then a fantasy is concerned, is asked to, here you talk more of imagination from real life. So, what have you done is you have innovative ideas can attribute to chance, and there are 4 type of analogies which are generally encouraged. So, what you do is you try to take a direct analogy, or you try to take a personal analogy, you try to take a symbolic analogy, or you try to take a fantasy analogy. So, you can use analogies and then try to come to your design and try to take a design out of it. There are tips for semantic methods. First, you try to define a problem, then use a direct analogy, then analyze your analogy, force a fit to the analogy, then generate ideas, then start developing ideas. So, these are the tips generally we give for developing a product. So, define the problem. So, definition of the problem is very, very important. Then you try to put all these analogies what we just now referred. Then you try to analyze the analogies and pick what is required, and then you try to forcibly fit that with respect to your product. Then you generate ideas for the conceptual ideas for your product, and then you develop the ideas. So, the analytical method are also called as systematic method. A morphological chart is a summary of sub-solutions to sub-functions. So, an analytical method is also called as a systematic method. So, any product, if it has to be developed, it has to be a systematic thinking process has to be used in developing the product. So, analytical method means you have a logical method to try to find out or come up with the specifications. For example, you can try to have a summary of sub solutions to sub functions. A product can have functions and some sub functions. For example, you have a car is used for moving from one place to the other. The sub function is it should not produce noise, or it should give you a comfort. This is a sub function, but what is your main function? Main function is only transportation. Okay. So, the morphological chart is a summary of sub solution to sub function. After completion of the functional analysis, we have to develop a matrix of sub functions as rows and possible solutions as columns. Then combination of a chosen solution to a chosen sub function should yield the design solution to the problem. So, these are all part of systematic method. After developing a number of alternatives, the best one is chosen by the designer. So, for example, for one particular problem, there cannot be one unique solution. Unique solution is not there. That is one thing which you should understand. There is always alternative solutions in design. That is very important. A designer should understand alternative solutions is possible, and you have to put all the alternative solutions and you pick a best solution such that you can cater to the needs. So, there are 7 steps. Morphology of the design has 7 steps. So, that is nothing but systematic way of solving the problem or solving or developing a product. See, the morphology of the design is study of the chronological structure of the design project. It is defined by phrases and their constituent steps. Of the 7 phases, the first 3 phases belongs to design and the remaining 4 phases belongs to production, distribution, consumption and retirement. As I told you last class, retirement is also one important parameter which has to be thought of at the design stage itself. So, there are 7 stages. So, out of 7, 3 goes here and 4 goes here. So, the first 3 phases stages are belonging to design. So, phase 1 is the feasibility study. A design project starts with a feasibility study. The purpose is to get a set of helpful answers to the designer's question. For example, a designer comes to you and says, can you try to find out a solution for this problem and I give you 20 rupees. Or somebody comes and says, I would like to have a material which is very brittle, very tough and which has very high strength and wear resistance. So, now immediately if you go back to the data book or if you look at many materials, it becomes little difficult for you to come out. So, first then what you do is you try to pick up, okay, material A, material B, material C, material D. I try to make an alloy of whatever it is. So, am I still able to meet out to the requirements of the customer? If that is there, then you can start looking at a project or start looking at a problem solution. If it is not so, then we try to scrap it at their level. So, that means to say, in engineering also we tell the students the same. You have a problem or you have a process, what you do is first you try to do a simulation and then try to see whether it is feasible to develop a solution for this problem. If it is not so, we try to scrap the idea. So, a design project starts with first a feasibility study. The purpose of this is to get a set of helpful answers to the design questions. I will take you and I will tell you an example of this metro rails. When metro rails were introduced at every place, people started saying that 50 rupees a ticket, so it is not a feasible model and it will not self-sustain. Please do understand, when government went for these metro trains, they were looking at how do people commute from place to place, how can we reduce the pollution, how can we try to give a better comfort life for the citizens. That is where their lookout was. So, they did not think first stage financial feasibility, they looked at all other things and over a period of time they looked at financial feasibility. Today Delhi Metro is very successful. So, for implementing this Delhi Metro, they did a first feasibility study and then they found out, yes, there is going to be a answer to this and our answer is giving a better result. Then let us start looking at problem solving skills. So, what are the problems as far as Delhi Metro is concerned? How many trains to be put? How frequent this has to be there? What is the investment should happen? And then if you say high speeds have to be achieved, so what should be the structural stability? All those things come into next. The first step in the study is to show the original need is valid or not. Okay. So, that is the feasibility study. So, feasibility study first is requirements, collection and analysis has to be done. Then what we do is we try to develop a design. If it is a product, then we try to develop prototype, or if it is a solution, software solution, other things, we try to do implementation, we try to validate and test our results and then we put it into operation. So, feasibility study is done. So, after the feasibility study, the requirements, collection and analysis of data is done and then from there comes the design, then we implement it, validate it. Any design you do, it has to be validated and it has to be tested with the customer. If you take a pharmaceutical product which is human health related, the testing phase takes a huge time. 3 years, 5 years, 10 years, they do it on rat, then they do it on this, they do it on that. But if you develop an engineering one, you do not have to undergo such a long time of testing. So, it depends from product to product. So, phase 2 is the preliminary design. We studied phase 1 which is a feasibility study. Then what do we do is a preliminary study. The purpose of this preliminary study is to find the best design alternatives. Then the preliminary design phase starts with set of useful solutions which were developed in the feasibility study. So, we look at alternative solutions and we now put down all the alternative solutions ahead of us, in front of us, and then look at, okay, what can we do? But now please do understand, you cannot go back and say the feasibility study I would like to relook. Now I see in the preliminary design stage I do not see any solution, so let me look at feasibility study. No, that is not accepted. When you develop a product and when you are moving forward and when you move forward in putting the requirements, you have to do the requirements and you cannot now go back and start reiterating your feasibility. Please keep that in mind. You can develop a product, prototype, keep revising their performance, but you can't go back and say about a product. Okay. Whether this product at all is required, that you cannot question. So, that is what we say. The preliminary design phase starts with a set of useful solutions which were developed in the feasibility study. The purpose of this preliminary study is to establish which of the preferred alternatives is the best design solution. So, out of the 4, you now start working on which one is the better one. So, again now here what do we do is we do concurrent engineering today, and we use the best material, the best manufacturing process, the best sales person, the best accountability person, the best costing person, all of them join together and start picking the best solution. So, many a times what happens, solution 1, 2, 3, 4, solution 1, 2, 3 and 4. So, the best solution is here. The best solution can be 20% of solution 1, 50% of solution 2, 30% of solution 3 also can happen. So, that means to say I do a cut here, I do a cut here, I do a cut here, I do a paste and develop the best solution possible. Many a times it happens in reality. Then what do we do is surveying the solution in tentative acceptance for closer examination. So, what do we do is we try to do evaluation of the product within our close community of friends or within the factory or within a confined zone where I would like to test my product and see what is the performance of it. Then you do it in a closed examination, you do a closed door evaluation of whatever it is, and who are very critical in telling you, okay, this is bad, this is good, this looks comfortable, something like that. And then what you do is you next project studies are undertaken to know as to how solutions will be feasible in future. Then phase 3, now what you do is you do a detailed design. You have a problem, you have evaluated the problem needs a solution, you have developed 4 solutions. So, now you have chosen the best fellow. So, one feasible solution, best solution is chosen. Now, after doing the best solution, now you work on detailed design. Detailed design. So, you look at best solutions and then you start working on detailed design. When you try to look at detailed design, here we try to put all our engineering knowledge, right. And many a times people skip this exercise and whatever comes they just take one solution and start doing it, and they are not pretty sure whether that is the best solution. Okay. So, that is what it is. After preliminary design, other studies examine the extent to which forces from surrounding or internal forces which affect the stability of the system. So, now what you do? You do a detailed design. So, you have decided there has to be a shaft, it has to be made out of some material, steel, and now what you do is what should be the dimension of the shaft? What should be the tolerance of the shaft? Is that shaft mating with another gear? So, what is it? All those things we will start looking at it. So, the goal here is to furnish the engineering description of the examined design. Till now, you have not talked about the engineering design. Engineering design helps you to move forward towards a manufacturing process decision or look forward for manufacturing feasibility. Okay. If this after this stage only or during this stage only, when engineering descriptions are given, you try to choose the best material and other things. Till now, we did not bother about shape, size, form, whatever it is. We thought, okay, this a crude solution was thought of. So, here we try to do a detailed design. The great feasibility is to show up to this point in designing. The preliminary design is developed as a master layout, which this as a basis, the detailed design or the specification of the component is carried out. After the detailed design is done, now people look forward for local vendors, people look for international vendors. They try to pass on the design and then they ask them, can you give the costing for it? After getting the costing, they just plunge it back and see whether it is feasible or not. Next is, as I said, planning the production process, because now that you have fixed the engineering specification, engineering design constraints, now what you do is you look for manufacturing processes. By the way, manufacturing process can also go back and say, oh, this is not possible, we cannot make this design. Can you make a oblong shaft instead of a circular shaft? Very difficult, you can't make a process. Can you make a square shaft instead of a circular shaft? And the design says, a detailed design says a square shaft has to be made. It is pretty difficult for a long, if you want to do extrusion, possible, and again in extrusion also square edges is very difficult. So, people always try to go back and say, no, it is not possible. So, can you convert this square into a circular one? And if they say, okay, it is possible, now you go back, redo the design, detailed design is relooked, and then they come back and say, okay, looking into manufacturing difficulty, we have converted the square into circular this thing. When you talk about a circular cross section, the production cost is very economical. When you talk about a square, it is slightly expensive. It is not that it is not possible. So, what we have to do is take a circular shaft and then you have to mill the surface, index it, mill the surface, and then you get a square shaft. It is possible, but it is time consuming, and the sharp edges will lead to stress or stress concentration. When you put it on mating, it is prone for failure. Okay. So, there can be back and forth going back between detail, design and the production process, but predominantly once the detailed design is fixed, and during that time itself a manufacturing expert is involved for decisions. So, whatever they take a decision there is then further taken down. So, in phase 4 is planning the production process. As mentioned in the 3 phases are in the field of engineering design, but the 4th phase and further are related towards management. Every part requires a detailed process plan. And here also I would like to bring to your kind notice, manufacturing solution, whatever you generate, manufacturing solution for a product, nothing is unique. You will have several alternative solutions. You try to take the best decision keeping time, material available, time, cost as the constraint, and then you develop or you prefer one particular solution. A solution which worked very good in one part of the world need not work in the same way in the other part of the world. Okay. So, a manufacturing solution, there is nothing called unique. You will have to choose a best solution at given the constraints. Okay. So, that is what we say, every part requires a detailed process plan, sub assemblies and the final assembly has to be given. There is a process sheet which will be developed for each individual product, and then there will be more information about what is to be, what all changes have to happen to the part such that it becomes a product. Okay. So, then the operation analysis is also performed. For example, operation means the movement. Okay, the first machine is here, second machine. Should I place all the machines one after each other? Can I place them in a haphazard manner? After this operation, what is the next operation? What is the total time I give and this operation? So, all these operational analysis, should I do it manually? Should I do it with the CNC? All these things happen. Then planning specification and a detailed new production and plant facility is in phase 4. So, you establish a plant layout is done in step 4. This step is particularly important because design features that lead to difficulty in productions are revealed. Okay. So, first 3 is feasibility, detail feasibility, then you look for alternative, then you produce a detailed one. The 4th one is towards layout, process planning and layout. The 5th is planning for distribution. 5th is how will I transport this part from the company or the production plant to the retailers. So, that is planning. So, the transportation cost can affect the outer design of the product. Just a simple example. For example, I said in the last class itself, table. Okay. So, today the tables are made into modular concept, they are disconnected and then they are packaged and then they are moved. Suppose if they want to push a fully assembled table, it might occupy a lot of volume and the transportation cost becomes very expensive. Okay. So, to facilitate handling, special strapping and palletizing may be needed. So, for example, if I wanted to distribute milk, should I distribute milk in sachet packets of half a liter? Should I do it in 1 liter? Should I do it in 5 liters? Should I do it in 10-liter bottles? Should I do it at 25-liter cans? Should I do it at 50-liter cans, or should I do it at 1000-liter barrels? So, all are distribution of milk, all are milk only. So, now I have to decide what should be my packaging. So, that is what we said, handling, special strapping and palletizing is very important. So, that is decided in planning for distribution phase in phase 4. So, the major decisions taken in this phase are designing the packaging for the product. Should it be 1 piece? Should it be 5 pieces per packet? Should it be 1 liter? Should it be 50 liters? So, that is what it is. Then planning the warehouse locations, very important. Today in eBay you go ahead and book, you order a particular item. So, now this item has to be picked up from the warehouse. So, should I pick it up from the closest warehouse or slightly far away from the warehouse? The next constraint is, if I pick one item from this warehouse, will it undergo the next ordering cycle? And if the next ordering cycle starts, what is the costing involved? Or if I go 50 kilometers away, if there is a warehouse where there are four items there, if I pull out one, nothing big is going to happen, then they can do it. And now each warehouse owner also tries to give you discount. If you try to use my product in my space, if you take items from my space, I will give you at a lesser price. Then immediately the eBay looks for all these benefits, and then what they do is either they try to give the benefit to the customer or they try to give it to the company. They decide the warehouse locations. Next is promotional activities. Promotional activities are very important. So, if you try to leave this product, if you try to take education as a business, as a college as a business, college as a product, institution as a product. So, for this product, the sale comes, the customer comes only once in a year. So, they do not have people join school or college only in June, July, whatever it is the season, only once in a year. Okay. So, that is the time they join. So, for that time they generally take decisions in month of March. If I have to take a decision in month of March, the college has to give a widespread advertisement starting from January to March, and they should not start giving the advertisement after April, because after April it goes in vain, because the student has taken a decision in March. So, that is what is planning for promotional activity. Okay. Next one is designing the product for conditions arising in distribution. So, this is also very important, designing the product for conditions arising in distribution. So, for example, if I try to move, for example, laptops, when they are moved from Malaysia to India, many a times they are moved by ships. So, what happens when it is moved by ships in the sea, the complete container rattles, it goes up and down. So, now individual laptops have to be packed. So, this will be packed and then it will be done. So, should I do and when you pack, it will be individual laptops packed and then they put it inside a container and then it moves. So, when it is individual is packed properly, even in the rattling, if it falls down from a height of 10-20 meters, nothing happens to the product. In fact, I have physically seen a test where people drop the laptops for designing the packaging. They try to drop the laptops from the 5th floor and the 6th floor of a building to the ground, and then they see what amount of damage it has created to the laptop. So, designing the product for conditions arising in distribution is also very important. Sometimes it can be humid climate, sometimes it can be a rainy climate. For example, eBay items are packaged in plastic covers, because all in hilly regions you can have rains. In a region like a flat plain, the temperatures can go very high. So, all these things are part of are to be considered in the planning and distribution. The 6th phase is planning for consumption. This is a very, very important phase. So, the consumption is the third process in the production consumption cycle. its influence on the design, so the design it influences more on the design, and this makes design little more important. So, the design for consumption includes the following factors: design for operational economical, design for reliability, design for convenience in use. For example, yesterday I took my son to a doctor. The doctor suggested two creams, cream 1 and he suggested cream 2. This cream is 100 grams and this cream is 25 grams. So, he said mix these two creams at a ratio 3:1. And now, if I had to maintain this 3:1 ratio, it is very difficult for me. I just have to pull it out and then try to randomly or more approximately assume that okay, this is 3 times and this is 1 time. Then I put it on a piece of on a vessel or on a plate, then try to mix it. When I mix it, I am not pretty sure whether the mixing has happened properly, and then I have been asked to apply for my son's skin. See, as a father, I am more worried, because if any ratio changes and if at all it affects his skin, what am I going to do? So, here this is not convenient to use. That is what I am saying. Design for convenience in use, it is not there. And many a times, many of the companies sell a wonderful product, but they do not attach a good instruction manual. So, it is not convenient to use. Okay. So, this is one, and the next time is okay. So, suppose I try to take oil in a pan and then I use it for frying, and after I finish my frying, I wanted to unload, or I wanted to remove the oil from the pan and put it into a container. So, now if I try to tilt a pan, it spills all around. So, it is not convenient to use. So, that is what I said, for convenience in use has to be thought of at the design stage itself. Then design for safety. For example, batteries, after it is consumed, we discard it left and right, and now slowly people have started getting education that it has to be discarded in a standard procedure. Earlier it used to be throw it here and there, and the next thing, same way for acids which are used for cleaning purpose, hospital waste. So, all these things were discarded left and right, here and there, and this is something which is very important, which has to be thought of at the design stage itself, design for safety. Then design for aesthetic features, design for maintenance, and design for adequate duration of service. So, you can't say every 15 days go to a shopkeeper and get my product service, my product will be wonderful. You can't do that. So, even today when people buy bicycles, the biggest problem in the bicycle is the pedal, it fails or the tire gets flattened. So, they have to produce a tire which does not get flattened, or they have to make a pedal which the screws do not fall off. So, here they do not need to go to a service engineer or a service station, they can keep continuing the product. So, all these things, design for consumption, when you think, all these things have to be thought of, and it has to be integrated into the product when you try to design a product, or it has to be integrated at the design stage itself, so that you try to get this right. Then to get service data that can give a basic for the product improvement for the next generation design, and for the design for different but related to the products can be taken, and then you can try to improvise every time. So, this point is more towards service data for improvising or producing the next generation of it. So, phase 7 is the planning for retirement. So, after the product has finished its life or its performance, now what do I do with the product? For example, I told you the batteries, the life of the battery is over. So, now what do I do? How do I discard it? That is the important thing. So, the fourth process in the production consumption cycle is the disposal of the retired product. So, today we are started designing products, or there is a requirement for the designer, product designer, that they should look for products where individual parts, almost all of them, fail at a reasonable time. For example, in a tube light, the glass does not fail at all. The tube, the glass does not fail, the closures does not fail, the gas fails. The gas fails. It's only because of this gas failure which does not further go for ionization. You throw the complete tube light. The glass can be recycled, the closures can be recycled, and then we do. So, now what we want is we wanted to develop a product as and when the gas degrades, the closure, we choose a material that also starts degrading, and the glass whatever you use, we try to make sure only it withstands for certain amount of time or certain amount of time period and something like that. So, this is what is now talked about. So, we are looking for a product which can all try to decompose or all try to lose their performance at a simultaneous stage, and when I throw it, I throw all the products are work to the maximum efficiency, or I try to reuse the glass and the closure. So, I go to a shop and then give this tube light which is not performing, ask him to refill the gas and start using it. The disposal of the retired product is very important, or reusing the product is also thought about. So, after retirement, what is to be done has to be also thought of. So, this is the phase 7. So, for a large and semi-permanent installations, the mere removal may pose difficult engineering problems. So, the designing for retirement must consider the following aspect: design to reduce the rate of obsolescence, designing physical life to match anticipated service life. This is what I was trying to talk with respect to a tube light example. So, with this we come to an end for lecture 4. So, today's task is try to choose a product. Let us take a cell phone. Okay. List down all the parts to the best of your knowledge. List down all the parts, 1, 2, 3, 4, whatever it is, and then try to write down what is their expected lifetime. Okay. Try to write the expected lifetime for maybe 10 of this. So, these are parts, these are all parts of a cell phone. Okay. Here you are writing the name and then expected lifetime. Then what do you do is you try to say the ways of disposal, and after that you also will say what is the weightage for individual parts in the performance, weightage of individual parts for performance of the product. For example, you take a cell phone, what is the weightage, this for example battery, what is the weightage of the battery in the overall performance of a cell phone, or what is the performance of the glass which is there on top of this, what is the performance of something else, vibratory part, whatever it is there in a cell phone with respect to its performance. So, I want you to write down the parts. You have to write minimum 15 parts. Let us make minimum 15. You will write down the parts. If possible, you will also put their figures, then it becomes more. You put their drawings of all the figures of this, then you try to write down what is the expected lifetime. Then if at all it fails, how do I dispose it? Not as a total phone, that individual part. Then what is the weight of the individual part with respect to the overall performance of the cell phone? Please try to make this table. Okay. And then what you do is you will see all the phases whatever we have studied are coming into existence. We will start with lecture 5 next time, but please try to solve this, solve these assignments, and you do not have to submit, but solve this. So, then it gives you a confidence, it gives you what are all the problems, and cell phone is today everybody has one. So, you can look at it and then start writing it. Okay. So, thank you very much.